Good morning everybody, and welcome to our experiment which we're going to be doing between two chemical compounds, one called lead nitrate and the other is potassium iodide. What we're going to be doing is a precipitating reaction where we're going to put the two compounds into a solution and they're going to dissolve and form a clear liquid. So that's lead nitrate in the first one. Then we're going to put potassium iodide in the other. And I've warmed the water up so we should get a quick dissolving. And then, so you can see that we've got a clear solution in both of those test tubes. But when I pour one into the other, we're going to get a reaction. And we're going to form potassium nitrate and lead iodide, and one of them is going to precipitate out of solution. Just focus that in. So here we go, and there we get our precipitation there. Nice, lovely, creamy yellow colour. Right, so I just had to look up quickly to remind myself which of the new compounds actually precipitated out, and it's the lead iodide. So we've got lead nitrate there and potassium iodide there. So the two compounds formed in the reaction are lead iodide and potassium nitrate. Now it's a lead iodide because lead is a very large molecule, and when it forms with iodide, that comes out of solution, and that's when you get this. And you can start to see it settled now, so you can start to see the actual compound lead iodide at the bottom. So we'll leave that for a few minutes and come back, and all this should be clear water and just the precipitates left at the bottom. What we're now going to do is going to do the same reaction. We've got the same two chemicals, lead nitrate and potassium iodide, and I put a certain amount of the crystals into the paper there on each side. And we've got a petri dish here that's got water in it, deionized water, and we're going to put the crystals on each side, and we're going to wait for them to dissolve into the water and see how they diffuse across, and we'll see a reaction, that yellow precipitate occurring hopefully in a line across the water. So I'll put them in there and we'll just wait for them to react with each other. So we've got the lead nitrate on the left and the potassium iodide on the right. And at some point we should see there, we get the yellow line forming there. Now you can see that it's nearest the lead nitrate, which is good, because that shows that the potassium iodide has dissolved quicker in the water and the lead nitrate has dissolved slower, because that's the biggest molecule. Okay, so we're getting the nice yellow precipitate along that line there. We've now waited a few days for the precipitate, the lead iodide precipitate, to settle down. So you can see there it's all settled at the bottom, and we've got the clear liquid above. So it then gives me a chance to take some small drops of the lead nitrate and we'll drop it into the potassium iodide, and then we can see the reaction occurring in very small bits. So there you can see the precipitate forming straight away and then falling down. Do it again. Oh, and a bigger blob there, perhaps more than one drop, and then another drop forming, and then we'll do a run of drops. We're now going to look at the chemical equation for the reaction between the two compounds that we were using, which was lead nitrate and potassium iodide. And conveniently, on the container holding our lead nitrate here, we have the chemical formula written out, which is lead nitrate. And we've got lead nitrate showing us having to have two of those ions to balance with the lead. So we'll write that one out. So that's lead and the nitrate. And there were two of those to balance with the lead. Now, we should know, just by memory, that the nitrate ion has a charge of 1 minus. So having two of those, that gives that an overall charge of 2 minus. And that tells us that the lead has in this ionic state, has a charge of 2 plus. So we don't necessarily know what charge lead has, because it can have various oxidation levels, but in this case, so our lead is 2 plus. And then the other compound, which is potassium iodide, that is potassium, which is K, and iodide, which is large I. Now, looking at our periodic table, we know that potassium, being on the left hand side in the first group, that has a charge of 1 plus, and iodine, being in this group on the right hand side here, group number 7, they all have a charge of 1 minus. So we can see that that's plus 1 there and minus 1 there. So that is balanced. So these two react, and it's a double displacement. So what that means is that the ions just swap over. So instead of you having lead nitrate, you then have lead iodide. So you've got lead iodide there. Now for that to balance, we know that we've got lead 2 plus. So we need, as iodine is only 1 minus, we're going to have 2 iodines there. So now that is 2 minus there. And the other compound that is formed is potassium nitrate. So that's potassium, K, and nitrate, NO3. Now then, how many nitrates are we going to need? We know that potassium is 1 plus, and nitrate is 1 minus, therefore that balances on its own. Now what you also often see in these chemical equations is the state of the compound in solution. So we know that when we mixed our lead nitrate and our potassium iodide, they both dissolved in the water. So we got, let's do it in green. So we got an aqueous solution for there. Let me put that in. And an aqueous solution for the potassium iodide. And when we did our reaction, we got a precipitate. So this lead iodide, that was a solid that came out in yellow, and the potassium nitrate, that was still in solution, so that is aqueous. Now, to balance it, we notice that we're going to have to do some alterations to the numbers of over on this side and on this side. So we've got 2 nitrates on this side, but only 1 nitrate there. So we know that the first thing we've got to do to get nitrates to balance is to put a 2 in front of the whole lot. We can't just put it in front of, do 2 nitrates here like we have here, because that then would unbalance the ionic compound. So we find that we've got 2 potassiums here, but only 1 potassium on that side. So again, we have to do the same thing. We're going to have to put a 2 in front of the potassium iodide. So let's see how we argue. And we'll just go through the ions individually to see that they balance on each side. So the lead, Pb, we've got 1 there and 1 there, that's fine. The nitrates, we've got 2 on this side and we've got 2 on that side because that 2 applies to there. The potassiums, we have 2 on this side and we've got 2 there. And the iodides, we've got 2 there because that 2 applies to the iodine as well as the potassium. And we have 2 here with that little 2 on the iodide there. So that's fine, that all balances. And the final thing we're going to do here is to look at why it is that the lead iodide came out as precipitated, formed as solid. And the clue to get that information is to look at the atomic mass. Now in another lesson I'll show you how to work out the atomic mass of molecules and compounds. But we know that the atomic mass of lead nitrate is 331. That's a molar mass. And of potassium iodide, that is 332. And of lead iodide, that's 461. Now you can see already that lead is quite a large component of that, because it's much higher up in the periodic table. So you can see we've got potassium there, and we've got iodine there, but lead is much higher up. That's number 82, and it has a, I don't know if you can quite see it, but it's an atomic mass of 207, so that makes it much heavier than the other elements. And potassium nitrate has an atomic mass of 202. So you can see that lead iodide has by much higher atomic mass than the other molecules. So therefore that's much more likely to come out of solution and form a precipitate. So you could say that the cut-up point is say 400, atomic mass of 400. If it's below that, you'll keep it in solution. If it's above it, it'll come out of solution and be a solid and precipitate.